Well, hi, good morning. Thank you for joining me in my shop. Today is February 13th, and yes, my cat has joined me here. Aha, stick. Yes, the power of that stick. Cat, you don't realize how important a tool that is. So what's up today with this radio? I think really kind of two things I want to do, two or three things. One is I want to do some voltage measurements underneath the plate and screen voltages on the various tubes and just see that they're all there and they're all within range. And assuming that comes out just fine, I think I'd like to check the sensitivity of the radio, its basic operation, so feed in some signals probably from the signal generator behind shadow there, and go through each band and just see if the sensitivity is up or down, or that in fact they do work to some degree. I've only picked up one shortwave station with this radio. I've only really tried once, so I really haven't given it a good go. But we're going to use the signal generator because I'll know how strong the signal is that's coming to the radio, so I'll be able to judge the output from it. You can also get a look then at the calibration of the pointer a little bit, because we still don't have the glass panel in front, so we don't really know where every frequency is as we tune around. And this pointer is at a random location on the string. It's not on any kind of set point on the string. Just on that note, a lot of these radios will have a mark somewhere on the dial back, or somewhere maybe even on the dial itself, as to where the pointer should be when the capacitor is entirely open or entirely closed, like at one end or the other. You have a point there that you slide the pointer on the string to get the pointer into the right place. It's all very important in making the radio operate well. So, voltage is first. What do you say to that, Shadow? That sounds like a good idea? I think it is. Okay, I think we're ready to start here. Turn that guy on. First thing I'm going to do is send over a broadcast signal around 1 million. We'll tune this. Oh, let's tune this. Does it? Oh, look at that. Put this roughly in the middle. It's roughly 1 million, somewhere around 1 million hertz. We'll tune in the signal generator. We already know the broadcast band works fairly well because we've been listening to stations on it. And so we can sort of calibrate the radio with the signal generator before doing the shortwave bands. Okay, I'm kind of doing this a little out of order. I think I should probably be checking voltages first, but I'm ready to do this. It doesn't really matter which one comes first. Here we go. Are we going? Now we're going. So how come my signal generator number here is 0? What's happening here? Something not quite right here. There we are. Sound coming out of the speaker. It's just a coincidence. Oh, no, I'll take it back. This is on the IF frequency. That's why we're hearing it. We need to go up to around 1 megahertz here. Okay, so we're around 1 megahertz. Right on 1 megahertz. Fairly strong signal coming out. Let's find it here. So there we are. Doesn't take a lot of volume to get it. Tone's not hurting it. There we are. So the signal generator is set at a fairly high level, in fact, suggesting the radio is not very sensitive. That's not terribly good. Now I'm going to tune the signal generator. It's a little easier to tune the generator than the radio. Just get it maxed out here. It is maxed out. So a radio like this should be able to hear this quite easily. Let me calibrate this guy first before I make a mistake here. I've already made the mistake. We'll put this here, put that there, put that there. Well, there we are. That's better. Okay. I should have calibrated my signal generator right away. So now it makes a little more sense, because we were hearing all those stations before. The radio can't be insensitive. So now it's showing a pretty good showing at this level, which is 100 microvolts. I don't really know for sure what's on the end of the cable, but somewhere in the range of 100 microvolts, and the radio's still producing. Let's go down a little lower. This is 10 microvolts on the antenna, and we don't hear anything anymore. Not surprising. Very good. Okay, so that gives us an idea of what we can expect on this band. What about the subsequent bands? So we'll go to the next band. I have to look at the dial here. Next band would be, I'm looking at it upside down. Looks like 3 megahertz to 6 megahertz, so 3 to 6. This would be like 4.5 in the middle here. 4.5 in the middle, eh? Let me turn down my lights a little bit here. You can see these numbers just a wee bit easier. Okay, somewhere around 4. Turn this up. We'll go flying by it. So there we are on this band. I'm not saying the frequency is correct. I have no idea. I do have an idea. 4.8 is that in the middle? Just take a peek here. It is. Good. Next band would be, okay, so if that's 4.8, this is going to be somewhere above 7 on the next band. 7 megahertz. Somewhere above 7. That's pretty good. Reception again, same. Okay, next band. Let me look at the dial here. It's going to be 10, about 10.3. Okay, so we expect this to go at 10.3. So this band's a little weaker than the last ones. And that could just be an alignment issue. If the radio were better aligned, it might be exactly the same sensitivity, but it's a little lower. You can see from the setting here. Okay, but it's working. That's the main thing. And the last band, there we are, around 15 megacycles. Around 15. So the next band. That's good. Very quiet here. Don't want to adjust this too much. So that's about where it was. Yep. So this band seems very weak. And what did I say? It was around 15. There it is with a heterodyne tone in it. The heterodyne tone could be because there's actually another signal sitting here. 15.7. Let's go down. Uh-oh. Still got trouble with the... Okay, so we went down some distance. Hey, we really went down. 16. So subtract 900, get 15.4. What happened here? The capacitor is going in the wrong direction. Oh, for crying out loud. Are you serious? Somebody come in here and fool with this thing? I just realized my phone has been in my pocket all this time, so I apologize if there's been cell phone interference on this video. Very sorry about that. Well, isn't that a... a kick in the teeth? That's a kick in the teeth, man. Wait a minute, it's going the right way. What am I talking about? Oh, yeah, this is going the right way. Oh, my world is falling apart. Wow, you can't leave these radios alone for a minute, or they just do stuff on their own. Well, let's finish off. I think I did finish off with the, or no, I didn't. I was having a funny time here. Let's go back here. Come on, come on, come on, come on. Oh, look at me. I'm losing my cool. I'm losing my religion here. Yeah. Oh, boy. All of a sudden, my world just fell apart. A disastrous thing. How can I make the same mistake and unmake it and remake it and unmake it and remake it? Okay. Anyway, it is what it is. So, but we can still continue with the sensitivity study on the radio. That explains why when I adjusted the signal generator and looked for the signal down here, I found it up here because the capacitor is going the wrong way. And because I'm doing the tests in the middle, you can't really tell that. Like if I did them at one end, I would have discovered pretty quick. Oh my gosh, everything's upside down here. I'm so bad at this. You know, like if there's two ways to do things, I'm almost certain to get it backwards. It's just, I don't know what it is about me. But there's nothing new. It's not a sign of old age because I've been like this all my life. Yeah. Maybe it's ADHD. I don't know. Okay, so what did we find out? We found out that all the bands are operating. They're all tuning roughly correctly. There's nothing really wildly wrong there. Some are a little more sensitive than others. That's probably just a simple alignment thing that needs to be done. So, so let's think about this now. I know, you know what the problem is. I know what the problem is. There's three things moving here. They got to move together. There's this, and that, and I've been paying attention only to two of them at any given time. Like a dummy. Got to get all three going the right way. So you can argue right now the pointer and the knob are going together. It's this guy who's backwards. If I reverse the string on the knob, then I'll correct the relationship here, but I'll uncorrect it here. Oh, why didn't I think of this earlier? There's three things that have to be taken into account. Right now I'm going to go and take my coffee cup into account and think about the situation here. I'm going to turn the power off, Jim. I mean, the good news is the radio is working quite well, even if it's ass backwards. Well, I was rolling through the schematic, the service manual rather, and I just stopped at this page and realized, look what they're showing here. They're showing that these dots are the index mark. 2.8. So this is the measurement of the glass in the cabinet. No, to the edge of the backplate. So they're saying you come in 2 3/8 inches from the edge of the glass. What is this measurement? I don't know what it is. let's go this way. So they have a line here. What's that for? And they have lines. Oh, here we are. I don't know about this line, but these ones they've named. 9. What is it? 9 to 15 to 15 and 21 megacycles? Is that what that means? 9 and 20? 9 and 20? Yeah, I guess so. I guess that's what they're doing. Why 6, 12? I'm not exactly sure what they're showing here, but they're showing something. The main thing is the starting point for the pointer. With it saying index mark, this must be the starting point. It probably has it written up somewhere. With the radio out of the cabinet, the dial calibration point should be located by making pencil marks on the back plate below the pointer. Figure 1 shows the measurements for these points with respect to the extreme edge of the back plate at the low frequency end. But it doesn't. These measurements are not from the edge. Oh, edge of the back? No. Edge of the back plate. I don't know what they're doing. Figure shows although figure 1 shows that dial scale for model blah blah blah, calibration measurements are the same. Calibration measurements. Dial calibration points. Make pencil marks on the back plate below the pointer. They mean the pointer slider at the top, I think. Shows measurements for these points with respect to the extreme edge of the back plate. But I don't get that. Okay, well, we know this stuff is here now, so later when I go to finally straighten out the pointer, I should be able to have success. It was right in the early part of the service manual. Okay, so what we're looking for, the reason I've got this up here, is to look for some voltage information. Is it here? Does it even exist? And we'll start looking at the power supply. And let me just zoom in a bit here so we can get a good look at it. You gonna tell us anything about the voltages here? 277 ohms. Oh, here we are. So 255 or 250, probably depending upon whether it's on radio or on phono. And if we just, here's some more voltages here. There's the negative voltages, excellent, that are the bias voltages that are developed. What about right up around the tube? Did they write any? Yeah. Very good. They've got tube voltages written here. Plate. What about the screen? So the screen would be here. Yeah. Screen voltage is written. Excellent. Okay, so we're going to be able to compare each tube's voltages with what's written on the manual. Excellent. Okay, good. Let me get all that ready to go. Okay, first one we're going to do is the rectifier tube. Rectifier tube, this guy here. In this radio, the rectifier tube was replaced by another tube. For all I know, the socket is rewired, probably has been rewired, and everything could be a little different here. So I think in this case what I'll do is I'm just going to poke around. In fact, see this big capacitor here, that big capacitor. Watch my cursor now on the little screen. If you follow this wire up, oh, you can't follow it up. Yes, you can. Follow it up. Follow it up. Why are you following it up there? Don't follow it up there. Follow it back. Follow it here. Here we are. Okay, I went flying right by. There's a capacitor right there. So this is connected to a filter capacitor. So just read the top of the filter capacitor. And there it is, staring us right in the face there. So just have to read it. At the top of that capacitor, I should find 250 volts. And then we can move on to the next one. Okay. So signal generator is disconnected. There's no antenna connected. There we go. Haven't had any smoke come out lately. That's kind of interesting. Now we're gonna have to run this on full supply voltage too. We can't be. Well, we could. I mean, just have to take 10% off the top or something. So I'm just watching the voltage come up here. 104. A little low. There we are. That's good. You can hear a little crackling. tone control, Jim. While they're crackling. I don't know, don't like it, but anyway, we're going to ignore it. Okay, so starting with the rectifier tube and going right on this big capacitor, we're looking over here, over here, over here at this meter. This meter here, which I've got switched. We didn't even switch it on. Duh. And we'll set this up to 500 volts. It's just warming up there. Just letting it settle down. Okay, we're ready to go here. 500 volts full scale, so this thing should go straight up when I do this. Straight up. Perfect. So that's the correct supply voltage coming out of the radio. Now we want to move on to the next tube. Just go up. We'll pick this guy. He should have virtually the entire voltage should be sitting on the plate of this tube. That's the next tube back. And the plate is, which one of those pins is the plate? I don't know, so let's pick one and we'll just see what happens over there. Nothing. How about this one? There we are. There it is. 250. Now does that tube have a screen? Yes. Oh, wait a minute. Yes. So I'm looking at the output tube now. Is that correct? I believe so, yes. Output tube has a screen also at the same, looks like at the same voltage. So we should find this voltage twice in this tube. So we're looking again. This is where I found it first time. There it is. There it is again. And that should be it. Those are all grounded, looks like. Not that one. Okay, that's good. So voltage is present, voltage level correct. Next tube back would be the detector tube here. That's this guy. Now they're showing it in two sections because it really is two tubes in one. And I believe they share the cathode here. This grounded cathode. And they didn't show it on this side. I think that's actually a mistake in the way they've pictured it. Not that it matters. So we want to go on the plate here. It's only 85 volts in this case, and there's no screen. So 1, I think I got the pin number right there, Jim. 2, pin 2. Okay, can we manage to do that? Pin 2, pin 2. This would be pin 2. So we're looking for 85 volts here. Looks good. Okay, so I would put this like this. 150. So 85, pretty much straight up again. There we are. Correct voltage there. Okay, we'll go to the next tube over. The all-important IF amplifier tube here. And this has got a screen with only 85 volts and a plate with the full works on it of 250. Plate is on 2. Okay, next tube back would be this one. It's in between the two cans, which you can't quite see there. Okay, and oh, keep the meter. Yeah, meters in view, meters in view. And I said it was 2. 2. So 2 would be, I think it's this one here. Interesting enough, so there's a wire. I'm about to touch this terminal here. There's a wire coming down from it, and that wire's going into the IF can, and it's all covered in black dust, all spread along it. And that's a good sign of high voltage. So I wouldn't be surprised at all that this works. Now I'm going to put my hand in front of that meter. A little bit tricky here. So 250 should be straight up. Now, there we are. Got the whole shebang there. And now pin number 3, next one over, should have 85 volts on it. Next pin over would be counting 2, 3 here. Well, there's the 85 volts. Okay, fantastic. That's great. Okay, next tube. This tube probably has a screen also in here. Oh, look at, you probably can't see it, it's so small on your screen, but this guy's two banger tube also doing 2 different things. So on this side is a triode amplifier, and on this side is a multi-grid converter, mixer. There's other names for it too. So we'll start with this side. This is the side that's responsible for the oscillator. If I remember right now, they put these dots on the oscillator line so you could tell the oscillator circuits, the local oscillator. You need an amplifier to make an oscillator oscillate, so that's what this is. So pin 3, and what do we find? 120 volts on pin 3 of the mixer oscillator do-it-all tube. Just right in here, I'm pretty sure. And there we're looking, once again, I'm looking at pin 3. 3 should be the plate at 120 volts. So we're going to flip this to 150. So 120 is up like this, something like this. Something like that. Pin 3. So I'm counting now. 1, 2, this is pin 3 here. Pin 3. Right there. Okay, I can look over and see the meter's gone right up 130 on the meter. Excellent. Very good. That meets, that comports with the requirement. Now we'll look at pin number 2. Right beside it, we'll have 250 volts. So in this case, be straight up again because I'm on the 500 scale now. And we're going 1 pin further. No, 1 pin back. So 2 is kind of hidden down here. There we are, straight up, 250. That's great. I think that's it. I don't think there's any more tubes to test. Is there another tube? No, that's it. That'd be the end of the tube voltage testing. All of them passed. They're all good. Now, what this could lead to, if you find a voltage off, is a bad resistor. That's usually where that leads. After you've done the capacitors, who else is left? A bunch of resistors. But in this case, it kind of suggests everything is just honky-dory in all respects. So that takes us back to the string. No, not the string. The string and then alignment. And I think I'm going to call it here for today. Say that's enough. Tomorrow I will sort out the string. I'll probably do it on my own. Just wow, how do you gotta get. So if this guy likes A and this guy likes B, it doesn't matter how many times you flip this guy between A and B, somebody's going to be unhappy. That's the situation I'm in with the string. Okay, just making it really clear in my own mind so I don't waste my time next time. Okay, wait a minute. All is not lost here. Let's see. Let's take a look. So I've got the pointer and I've got the knob lined up. They're working together. Problem is this guy's going the wrong way. Okay, easy way to fix it is to reverse this string. Now I reverse it to the way it is now because it looked to me like the alignment of the string in here would work much better. Twist it around. Kind of dumb. I should have I don't know. Anyway, I did what I did. The string is still getting on top of itself in here, but it did work better. Now I'm looking at very carefully at the alignment here. There's something curious about this, in that there's 3 sections here, and 2 of them were polished. These 2 are polished, so they've had string in them. I'm wondering if this is really where the string should be, in this middle one. How would that ever help? How would that ever help? Because you see, when you look down in there, so this is the string here that's coming up. This one over here, the other one, just ignore that. That's not part of the picture. It's down there. So looking at it from an alignment point of view, it looks like the string coming up would be pulled towards, this side, and the string here coming from the far corner be pulled towards the other side. This is exactly the way you would want it. So, so here's the thing. I can reverse it here, I can reverse it there, I can reverse it here and there. I can't do anything about the pointer. The pointer is sliding on that string, it's going to do its thing. I can't reverse this. Can I? Can I? No, I can't imagine. No, this can't be reversed. So things have to match this. So right now, the knob matches the pointer. This is the guy that's reversed. On the instructions, the string is showing the other way on here. But I'm sure if I do it the way they suggest, we're going to have string bunging up here all the time. But what else can I do? I got to try that. Okay, let's try it. Let's try it. I mean, how many options do I have? I don't have any options. The only option I have is to reverse it right where I'm going to reverse it. Okay, first I want to take off some of the tension here. Take it off here too. So, just before doing this, I'm going to look at the diagram. So you see it's coming from the far corner over the top and around, and then it's exiting. After going around a few times, it's exiting down this way. Over the top, out the bottom. Over the top and out the bottom. Over the top. Oh no, up, up, up. Over the top and out the bottom. Wasn't it? Up. Rotate. There it is. Okay. Guess I should have done this before. Okay, here we are. We're looking here. So it's coming from the far corner. See, right now I've got it coming over the top, but it actually should come underneath. And you can tell from this, it's underneath and to the back. And then it comes 5 turns and then out the front. And I think I cheated and did 4 turns. Thinking I'm smart enough. Okay, I think so. Bottom at the back, bottom at the back. That's what I have to remember. Bottom at the back. Bottom at the back. There's a kink. Don't want a kink in the string. There we go. There's another kink coming. Don't pull it. Yes, I'm talking to myself here. Okay. Up from the back, over the top, around we go. Put these strings back on. Okay, and then this one. Feels like a lot of tension. Wow. Wow, that's a lot of tension on there. That could help. If you get the tension high enough here, the string cannot run up over over a previous turn. Instead, it'll push the turn. It's tricky to get that just right. This doesn't feel good at all. So these surfaces, it's counterintuitive. They need to be slippery. It's counterintuitive. Okay, what do we got done? Here we go. Fantastic. This is, oh, hey, we got it in the right direction. Now, what's happening here? It's almost ready to dismount. Oh no, I got to slip the string problem now because this isn't where it should be. So if we put this knot right there, this should be all the way closed. So to achieve that, I have to back off the string tension coming down here. That's a lot of tension. How am I going to do that easily? And doesn't take much. Oh, I don't know how much to slip it now. To have it there. I need to have it set. We'll take it off one here. Every time we do this, I figure I'm going to break the string. Spot. No, I gotta actually hold the other string. It was designed not to slip, right? So I'm not having much success here making it do that. I'm going way up under here. Not doing well at all. This is not going well. What's happening here? Suddenly it was the easiest pie. Wow. Phew. Boy. This is not going well at all. Like no hope of it pulling it this way. Let's go all the way at once. And now I'm going to see the string get all tangled up here for sure. It's already on top of itself. Oh boy. moving this over to here is not, it's just going to make the situation worse. Gets in there and it stops. Notice the string is not, the tensions come out. Did I not put it back? Oh, I didn't put it back on. Oh, for crying out loud. Don't break, don't break. There. Okay, what do we got now? This looks good. Okay, the knot has gone right up into the wheel here. I'm not too worried. We're all the way to the right. And this is closed. Tell me it's going to work. And we're coming up on the closed. Get there. Ooh. So the knot is starting to go up. See, you know what I found? I found this. This is kind of a heartbreaker. Here's the original spring. See how small it is? See the original knot, how close it is? And I've gone and put a bigger spring in it. I put my knot way back here, and so I've got an apparatus now that's 3 inches long, and it's interfering at the end. Is it interfering bad enough to worry about? It may not be. What happened? Just now. Jumped off here. There's no reason for it to jump off here. Jumped off here. Probably jumped off here. I didn't see it, but it's on video. Oh man alive, I can't believe it. You know what, I think I'm going to stop at this point because this is it's a little late in the morning and I think I've exhausted my supply of tolerance here for the situation. But a string. Oh well. See you tomorrow.